Hello, welcome back to SHARPEYS workshop. Some people have been messaging me asking me to do an update or a bit of a beginner's video on Mig Welding, which is handy for me because I can use some of last week's footage. So let's crack on. So the same as last week, we've got our visor and our gauntlets, and we've got our hose going through the bottom of the door and a bucket of water handy, and I've made myself a makeshift welding table, and I've still got my tea towel on my visor from last week. But this time we've got two cheap MIG welders off eBay. Now this is one of your cheaper welders that I picked up from Clark. I mean, I've had this years. It's not working at the minute, I've got to fix it. But if we run through most of these cheaper welders, they all come with presets. Very rare you can adjust the voltage like you can with wire speed. So your preset voltages. So obviously one is your lowest voltage. To get the others to go into max, minimum 2 and 3, you have to put it onto A. Tells you there, look. Another thing with gas or gasless machines, if you're running gasless, you have to reverse the two polarities in your connections. So like negative is going up to your torch and positive is going to your ground. If you're running gas, you reverse these back to normal, so your positive is going up to your torch and your negative is going to your ground. Now this one I've got here, this is just a gasless only machine. It's a very cheap machine. I think I paid 100 quid for this. You only get 2 voltage settings and then your wire speed. The downside to this one is for such as car body panels, things like that, it'll be alright. But because it's only got your 2 voltages, it won't tattle thicker steels, thicker materials. But for such as out up to maybe a millimetre, you'll get away with. Inside these smaller machines, well, they're all basically the same, whether it's big or small. But in these smaller machines, I only ever use small reels. If you start putting big reels of wire onto these smaller machines, you're going to knacker your motor up. I've seen it happen time and time again. It's a pain in the neck, I know, but you're better off using a small spool on a small machine. This is your tightening. You get your wire, you feed it in there. I'll show you a close-up in a minute, but you feed it through there, and when you come to tighten it up, you need to be able to pull it on and off like that. Don't over tighten that. The more tension you put on this wire, if it jams up at the other end, you'll get what you call a bird's nest in here, where it'll keep feeding it through and it just keeps jamming it up till it all comes out and it's just a big bird's nest. Right, this is your wire clamp. I say that needs to be able to spring on and off. You don't want that over tight, because if you jam up on your nozzle, if that's over tight, it'll just keep feeding wire, and it'll end up getting a bird's nest in here, or it'll end up jamming up in pipe. So don't over tighten that. That spool there, when you pull your trigger, that's your motor. That's what feeds the cable through, or feeds the wire through. On this is flux cord wire. It's silver and it feels greasy to the touch. It also looks like stainless steel wire, but don't get it mixed up because stainless steel won't work. So if you're running a no gas or you're running gasless, you want flux cord wire. Now, unlike the stick welding with the MIG, it's up to you to keep your distance. You need the same distance from the surface all the way through. And really the only thing you've got to worry about is your wire speed and your voltage. Let's start off with the lowest voltage and your lowest wire speed. We'll do that now and we'll see what it looks like. As you can see, it's not really welding, it's just making pretty pictures. So there we are, that's the lowest voltage, lowest wire speed. You can see, well, blip, 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 blip. It's trying to make a connection, but the wire's just not coming out fast enough. So in this case, this dial goes up to 10. So, and we've tried about 5, but we'll leave it on the lowest voltage. Now that's a little bit better, we're getting some penetration, but it's still a thin bead of weld. Right, so that were a little bit better. Now we've got to number 5, which still blip 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 blip, and we're not getting a decent spread of weld. But we are getting the penetration, so I'm going to leave voltage alone and just turn the wire speed up a little bit further. So that's a little bit better. So next time I'm going to turn it up to 8, which is another notch on the wire speed, and slow down a little bit with me pulling along with the nozzle. Now for me, on this thickness of material, this is about 18 gauge. That's about the best weld I can do with a gasless machine. I slowed down with the nozzle, the speed's set about 8, and I'm still on the lowest voltage. Right, so that started from the lowest wire speed, the lowest voltage. I'm working my way through till I can find a weld, because these machines aren't all calibrated the same. What's set on 8 on here might be 5 on another machine. I know my old Clark welder, that were spot on about 4 for this sort of thickness of steel and the lowest sort of voltage. So your wire speed you're just going to have to play with. But start with the lowest voltage and go from there. If your wire speed's too high and you're not getting enough voltage, you'll find that your wire is shoving your hand away from the workpiece all the time. You could feel it just push your hand away. So you turn the wire speed down a little bit. If you're constantly getting thin welds and you're on the lowest voltage, try slowing down. As you pull your torch along, slow down. That way you're going to get a little bit more penetration and you're going to get a little bit more wire onto workpiece. That's about as much as I can tell you on this. I'm going to nip into work and show you a gas machine that I use at work and show you the difference in quality of welds. Unfortunately, that machine, I think, with the bottle, costs around 700 quid. Us as DIYers can't afford luxuries like that most of the time, unless you've got plenty of cash. But the difference in weld is astronomical. And there she is, my baby, look. As you can see from under the flap, basically the same. There's no difference between the more expensive welders and the cheaper home or hobby welders. You've still got the same feed system. The difference with this one is the coil of wire is copper. It's sort of a copper colour. The wire clamp system is the same, only this one gives you a little gauge to give you an idea how tensioned up it is. The pulling motors are the same. One of the disadvantages to a solid welding wire for gas welders is it can rust. This is a roll I took off just after Christmas because it got condensation on it and it's just absolutely caked in rust. If you try and weld with a rusty wire, it just won't have it, it'll just keep popping. So if you're welding with a gas machine, you have to make sure your gas bottle's turned on first. If it's a disposable bottle, generally it's a little black knob on the top of the bottle. So once you've turned your bottle on, I find it best to give the system a quick purge, which you basically just plug the machine in, pull your trigger as if you're going to start welding, and see if your gauges drop and then come back up. That way you know you've got your pressure. I always work to a rule of thumb of about 20 to 30 psi, somewhere in that vicinity. Here I'm going to do a quick run of weld with no gas on, so you can get an idea of what it looks like. As you can see, not very pretty, and I don't think it had owed anything. And in the next one, this is with the gas on, but the same wire speed, same voltage. Here I worked through a few welds again, same as I did with the other one, just adjusting the wire speed, and as you see the final one at the end, that's the one that I'm happy with. So that's the one that I'll work with. And when you finish your welding, always remember to turn the gas bottle off. It doesn't matter about adjusting the gauges. You can purge the air out of the system by pulling the trigger if you want to. It's not a flammable gas, so the only thing you've got to worry about is your pocket and wasting gas. Well, that's helped a few on you out. You know, I say what I know about welding, you can write on the back of a postage stamp anyway. I'm just a DIY, I've done it for years. But the same rules apply with MIG welding as with stick welding. If you're doing it indoors, in a garage, in a shed, when you finish welding, stay in the garage or shed. Keep an eye out for any smoking, any hope that might cause a fire, because them splatters can stop warm for ages. We have had cases at work where I've been welding away and it's caught over a damp rag. In fact, there's even a case where we went in for his dinner and come back out after I've done some welding, and there were a lump of rag underneath the ramp that were on fire. But that was fine when I left. So it's just to show you. I mean, me personally, it's only because I'm filming, I'm doing it in here. As a general rule of thumb, I like to be outside. It's a lot safer. You're not sucking any fumes in. There's less chance of a fire anyway. So stay safe. Don't forget your gauntlets and your mask. Most important. Don't let anybody look at your welds. And have fun. See you next time.